Hello guys, teacher M here. In this video we're going to do an example of converting a perspective formula back to Fischer projection. The first thing you need to do is to number the carbons in U-pack order, assign R and S, draw the longest chain downwards, and assign R and S name in the projection formula. So this is the molecule. Okay, so let's number the carbons following U-pack numbering 1, 2, 3, 4, 5. And then the next step, we need to assign R and S to all asymmetric carbons. That's carbon number 2, 3, and 4. Carbon number 2, OH as priority number 1, followed by this carbon bearing a carbonyl because it has a carbonyl. We pretend that's bonded to two other oxygens. So that's priority number 2, and this carbon number 3 will have priority number 3. So you're going 1, 2, 3. We are going counterclockwise around this carbon. So it's an S. Our smallest group has a dash bond. So that's an S. Next carbon, OH has priority number 1. Carbon number 2 here will have priority number 2 coincidentally because of the carbonyl, because they have the acidic group. And then this number 3. So we are going 1, 2, 3 around this carbon clockwise, but our smallest group has a wedge, so it's not an R as clockwise, it's gonna be an S. For this one, you have OH priority number 1, the whole group priority number 2, this carbon number 2, and then number 3. So you have 1, 2, 3. You're going an S. Our smallest group is bold wedge, so the true assignment is an R. So now we need to draw the same molecule following the carbon numbering in red. So we've assigned the RS configuration, and if you don't know how to assign R and S, please use the link below in the description to get over 1 hour of practice and worked examples showing you how to assign R and S configuration in a molecule. So on carbon number 2, it should be an S. You have OH and hydrogen. So the only way to get an S is to put your hydrogen to your right and your OH to your left. Because remember, the bonds that are here, these bonds that are here, they have the wedge bonds, right? Those are bold wedge bonds. Okay, so no, this guy will have priority number 1, this priority number 2, and the rest of the carbon priority number 3. So you're going R, but our smallest group has a bold wedge bond pointing towards you. So the true assignment of this carbon is S. It's S, and that's what you want it to be. So the only way you can get an S is by putting your hydrogen to your right and OH to your left. Same thing with carbon number 3 here. Carbon number 3 here, you need to put your hydrogen to your right and your OH to your left. Because again, this carbon, looking at this asymmetric carbon, OH will have priority number 1, and the group containing the carboxylic acid will have priority number 2. The rest of the molecule down here is priority number 3, even before we put our OHs, based on our biggest group out here, which will evidently, after drawing the whole molecule, you will determine that carbon here will have priority number 2 and this number 3. So 1, 2, 3. You are going R, but our smallest group has a bold wedge, so the true assignment is S. So we confirm that our carbon number 3 is S, as in this perspective formula. So it's S, S. Going down, carbon number 4, we need an R, so that means we should be going on here. We need to go S, and because our smallest group will have a wedge bond, we need to put it to your left, and then the OH will be to our right. Now if you draw it and you find the other ways, you just erase and switch these two bonds, put hydrogens the other side, OH the other side. But let's confirm that this is an R. OH is product number 1, this carbon product number 2, because you have 3 other carbons and a three other carbons and 2 oxygens at the terminal end. And here you just have 1 carbon and 1 oxygen. So this is product number 1, this carbon product number 2, and this product number 3. So you are going S, but our smallest group has a bold weight bond. So the true assignment is an R. So you see, you followed SSR. So this is the correct Fischer projection. But because we're going for the Fischer projection, we're not gonna show our wedges on the vertical position. We just need lines. So the answer here is just this drawing. Okay, just copy what you now found, only don't show the wedges. Beautiful, 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 beautiful. Ah, you see, you're getting these things. I wonder how I teach these things anyway, and people get it. Teacher M here. God bless you. Subscribe, call your friends, do everything you can do to get your friends here. Thank you.